This is the Bananalogue touch-activated sequencer keyboard, or TASK. It's a multi-channel analog sequencer in the eurorack. Probably one of the most powerful and flexible analog sequencers ever created. I'll show you some of the stuff you can do in a moment. First, let's go over some of the features and specs. It's 48 HK wide and swivel enough to sit in almost any rack. Here's the power entry is clearly marked. There's also 2 trimmers on the back. The sense trimmer is going to control how sensitive your touchpads are, and press is going to control the response of the touch output, but we'll go into that in a moment. The unit has 7 inputs, a switch, and 24 outputs. The outputs are grouped into sequencer output, keyboard output, and then there's a single gate output for every of the 16 steps. Looking at the front panel, you can see that the task has 16 columns, numbered 1 through 16. Each of these columns is to have its own gate output that goes high while the column is active. There's also 4 rows, A, B, C, and D. The touchpads are gold-plated. It'll trigger with, I usually wear gloves. It'll trigger with gloves on, but it's obviously going to be more sensitive with your skin. Let's look at the keyboard outputs first. That's going to be scale, gate, and touch. The key switch is also related, and I'll talk about that in a second. But first, the scale output is going to be a 0 to about 4.8 volt output, 0 at step 1, and about 4.8 at step 16. And this is in 0.3 volt increments. Here, I'll just put this into the Mordax so you can see that. We got a voltage monitor on the Mordax. At step 16, you can see it's about 4.84. And at 1, it's going to be 0 volt. As I move up, it's going to move at about 0.3 increments. This scale is completely separate from the sequencer. This is available, always available, regardless of what your potentiometers are set at here. Gate output is going to give you a 5 volt gate whenever a touchpad is touched. I'll show you that here. And it's held high for as long as I touch. The touch output is a minus 5 volt to plus 5 volt output. And it's responsive to touch input. So as you can see, when I press with the glove, it's not as dramatic. I'll take the glove off here. You can see that. Again, the sensitivity of that is adjusted by the trimmer on the back. I usually like to keep it pretty high. I'm going to illustrate really quickly what the keys switch does. It basically turns on or off whether their keyboard is active. Right now, I just got a clock source into the sequencer. And with the keys off, when I touch, it doesn't interrupt the sequencer. With the key switch on, now where I touch, it's going to hold the sequence until I let go. This could be useful, say, for instance, you don't want to interrupt a running sequence. So let's switch the keys off, and now I'm going to pull the gate out of that cue. For instance, let's use it into the rewind. Somehow, when I touch, the gate from the output is going to go into the rewind. But it doesn't matter where I touch on the keyboard because I'm just getting that gate. Contrary, if you do want to turn on the keys, this can help you to tune a specific column, for instance. The sequencer outputs A, B, C, D, and A, B, C, D is where you're going to get your CV information from the potentiometers. Obviously, A output is the output of row A. A, B, C, D is a special, and it's tied together with a vertical clock and vertical reset, and we'll talk about that in a second. But first, let me just quickly show you. We'll take the CV output from A, and I'll plug it into the Mordax data voltage monitor. Right now, we're on step 1 of A. So when I adjust this potentiometer, you're going to see the voltage change. Now, the real power of an analog sequencer is that this voltage is entirely continuously variable. There's no digital stepping. It's from about 0 to about 5 volts. I'm going to take this control voltage now and bring Asuna to a oscillator. Then I put the oscillator upward into the data and then change the mode to tuner. Now you can see as I adjust this, we should see the tuning change. There we go. I don't have those very good ear for pitch, so a tuner can be helpful if you want to adjust the steps that way. And you can also send it to a quantizer, obviously. Let's look at some of the inputs now, and we'll start with clock. I've got this DCS2 section set up as a LFO, and we may use the pulse out from that to drive the clock. And you can see it starts to move horizontally. If I adjust the clock, it responds to that. And if we get up into audio rate, this now becomes basically a graphic waveform generator, but I'll show you that later. Next input is going to be reset. I'm going to pull a gate off of, so let's say step 13. And now when it gets there, it's going to reset. Now it resets at that point. So if I use step 13, it's going to give me a 12-step sequence. Let's say if I put it into 4, now I should have a 3-step sequence. Reset, however, is not tied to step 1. It's the last touched column. So if I touch mime, now when it resets, it's going to go to 9. If I touch 5, now when it resets, it's going to go to 5. This allows you to vary your sequence length as it's running. Rewind is going to just change the horizontal direction. So I'm taking the data out from the keyboard and putting it into rewind. Now when I press, it's better run backwards. Hold. We show that. We take a data output, put it into hold, hit it holds. The random input is a little bit different. If I just send a clock to the random, it's not going to do anything. It needs a clock at both random and reset at the same time. And show you that. And I take this clock and give it to both reset and random. And now you'll see, and if I vary the clock speed, it's going to vary when it picks off random. So as I said before, the ABCD output is tied to the vertical clock and the vertical reset inputs. If I have this one set up as a LFL again, I'm going to take a pulse out. We're going to, instead of running the horizontal clock, we're running the vertical clock. And you'll see that ABCD now begin to step. This is what I mean by multi-channel analog sequencer. We have a horizontal sequence and a vertical sequence. If I take the ABC, the output of that, this is just set up as a oscillator. Then take the control voltage out of the ABCD into the input here. Let's listen to that. So now really easy to see we have a 4-step sequence running in the column. Let's take that clock and give it to the horizontal clock. So now we're moving horizontally, but I still want to step vertically. So now I'm going to take a pulse out from step 16, give that to the vertical clock. Now every time we hit 16, it's going to step down. Now we have a 64-step sequencer. Let's see what that sounds like. Now, V reset, that's going to be your vertical clock reset. So say for instance, as I'm stepping through here, I get stuck on in B for some reason, and I want to get back to A. Vertical clock reset. Boom, now we're back to A. I should also mention that while I'm set up again in that 64-step sequence, I should mention also that the ABCD outputs are also still active. So you can always pull the information from row A off of the A output. ABCD just gives you, this LED indicator will let you know which is active there, but you can use all of these at the same time. I have the task set up again, just a clock running in, and we're looking at the control voltage out. If I run that clock up into the audio rate, we've essentially made a voltage controlled oscillator out of the task. We're just doing the 16-step sequence here, and we've got manual control over every breakpoint of the waveform. So now we've got basically a graphic waveform generator. We'll show what that sounds like. Now remember, if this clock is under voltage control, now we've got a VCO. So let's add some control voltage to the input of the clock. If I had another task here, I could use one task to then sequence a second one in VCL mode. Because of the nature of the bit stepping through a staircase waveform, it's going to sound kind of digital. But if we take that output and we run it through a slew, well, let's do that now with this. It's on using this VCS to slew that waveform. Now we got something looking closer to a triangle. We'll listen to that real quick. If we take that audio rate signal back down into sub-audio, we'll turn down the clock and do that. You can see we've got ourselves basically a very complex LFO. Again, we have full control over the breakpoints, and I can also slew that if I want to get some different responses. This is also another way of thinking of that is like an extremely complex envelope generator up to 64 steps, which also has reset and can run backwards or be held. So you can get incredibly dynamic voltage control modulation out of the task. It's just that easy. So that's the basics of the task. As you can see, there's a lot of output for expression. There's also a lot of ways to self-patch within the task using gates and inputs. I'm going to set up a slightly more complex situation now to show you basically like use case scenarios. All right, we moved some stuff around the rack, joining the VCS2 and the task. Now we also have some drum modules, ZCL, VCF, VCA, and just to give you a little demonstration of what you could do with a very small system and the task. We're basically going to use these day outs to trigger the drums, and then we're using DCA of the VC to control things like the pitch of the oscillator, pitch of the drums, and cut off of the filter. Let's listen to that now. see how quickly we can make a very complicated or dynamic patch with just a few modules and the task. I've simplified the patch in the last example. In this case, we are just using the VCO, VCF, VCA, and an envelope generator. But we're going to be clocking the task with an external drum machine. This way we're not just getting clock, 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 but we can program where we want the steps to happen. I'm also using these gate outs to do some slew. So you'll hear a slide, but only on the steps where I've selected the gate to do that. Let's listen to that now. This is the same patch, essentially. I've just removed the Mordex data and replaced it with another analog sequencer. I wanted to show you a real quick trick you can do. I'm still clocking the task with the external drum machine, but I'm also using step 11 and 16 to clock this sequencer, and then their CVs are going to combine to control the oscillator. This way, for instance, you could set up transpositions that would happen automatically when you reach a certain step if you have two sequencers. Which just plays real quick for you. Finally, I'd like to talk about using the task as just a keyboard or a preset manager. And what do I mean by preset manager? Well, imagine, if you will, you're doing a live set and maybe you're getting note information into your system from a MIDI to CD converter or another sequencer. But in between songs or even during songs, you need to make drastic changes to your analog grid. Well, the task gives you access instantly to 4 channels of CD parameters. So say, for instance, you could use a channel A for like your envelope decay or your filter cutoff, and you can make those changes. But basically, consider this your memory. You could preset this ahead of your live set so that when you needed to make a change, like a drastic change to your envelope settings or something, you could just, boom, pluck that off the task. Then you might also be thinking, it's really small, and it really is. It's about the width of my hand. It's about as small as we could possibly make a fully featured 16-step analog sequencer. But actually, the touchpads or the same exact width as a standard key tap on a mechanical keyboard. So if you're used to typing, you should be able to play this. And remember also that if a sequence, you have a vertical and a horizontal sequence running, if you switch the keys also so that they don't interact with the sequencer, you're still able to access the scale, gate, and touch outputs so you can add some expression to sequences that are running or, set it to something completely else. In this example, I've got channel A and B controlling the volt octave and FM on the VCO. Channel C is doing cutoff on the filter, and channel B is doing control voltage over a decay on an envelope. And I could just, play it as a keyboard. There's every reason why you couldn't set this up to be a chromatic scale or microtame. You could also, for instance, send each channel to a different VCO, 2 men to a chord, and then you've got like a chord that you could, trigger 16 chords off, basically. Thanks for joining us on this video introduction to the Bananalogue task. One of the great things I just wanted to mention about the task is that it doesn't impart any aesthetic on the end user. Like you could use this to make like weird generative experimental ambient music or acid, whatever you wanted, or whatever this circus hash shit is.